Welcome back to our channel. We are the Lab Group 21, and for today's video, we will be showing you how we performed the fourth lab experiment with the title Ohm's Law. Enjoy watching! In this video, our objective is to verify the Ohm's Law principle. And the materials needed is the PhET Simulator Circuit Construction Kit DC3.
Procedure. This is the procedure for laboratory experiment number 4, Ohm's Law. First, we divided each task to the members. Second, we constructed an electrical circuit using the PhET Simulator Circuit Construction Kit DC. The circuit has the following materials: wires, battery, resistor, switch, ammeter to measure the current flowing in the circuit, and voltmeter to measure the voltage. Third, we proceed in doing the 5 trials and set the resistance using the resistor in an increasing value while the experimental voltage remained constant. Fourth, we recorded the values of the resistance, experimental voltage, and experimental current in the table. Fifth, we computed the theoretical voltage and theoretical current using the formulas given, and recorded the values in the table. Lastly, we wrote our discussions, observations, analysis, and conclusions, and we submitted the laboratory experiment before the deadline.
Let's move on to the table. The number of trials can be found in the first column, the resistance measured in ohms in the second column, experimental voltage measured in volts found in the third column, experimental current measured in amperes found in the fourth column, theoretical voltage also measured in volts found in the fifth column, and theoretical current also measured in amperes found in the last column. Trial number 1. Resistance 10 ohms, experimental voltage 20 volts, experimental current 2 amperes, theoretical voltage 20 volts, theoretical current 2 amperes. Trial number 2, resistance 20 ohms, experimental voltage 20 volts, experimental current 1 ampere, theoretical voltage 20 volts, theoretical current 1 ampere. Trial number 3, resistance 30 ohms, experimental voltage 20 volts, experimental current 0.67 ampere, theoretical voltage 20.1 volts, theoretical current 0.67 ampere. Trial number 4, resistance 40 ohms, experimental voltage 20 volts, experimental current 0.50 ampere, theoretical voltage 20 volts, theoretical current 0.50 ampere. Trial number 5, resistance 50 ohms, experimental voltage 20 volts, experimental current 0.40 amperes, theoretical voltage 20 volts, and theoretical current 0.40 ampere. Next part are the computations. The formulas given are VTH equals IR and ITH equals V over R. In trial number 1, theoretical voltage, V equals I multiplied by R, wherein I equals 2 ampere and R equals 10 ohms, which give us the value of V equals 20 volts. Next is theoretical current, I equals V divided by R, wherein V equals 20 volts and R equals 10 ohms, which give us the value of I equals 2 ampere. The same process was done in the 4 remaining trials.
To verify Ohm's law principle, we use the PhET simulator to construct an electric circuit, which is the path through which electric current flows. Ohm's law shows the relationship between the current, voltage, and the resistance. This is the basic law for current electricity, which was discovered by a German physicist named Georg Simon Ohm. It states that current flowing to the circuit is directly proportional to the voltage and inversely proportional to the resistance in the circuit. Ohm's law in symbols is given in the equation V equals to I R, where V is the voltage, I is the current, and R is the resistance. Voltage is the potential difference between 2 points and it is measured in volts. Current measured in ampere is the rate of flow of electric charges, and resistance is the ratio of the potential drop across the material to the current flowing through it. The unit of resistance is in ohms with symbol omega. The application of Ohm's law allows us to identify the characteristic of a circuit, such as the voltage of the battery, current flowing through it, and resistance of the electrical circuit.
Using the FET simulator, we observe that the electrons travel from positive to negative. However, if we get the current flow or the conventional current flow, the current flows from positive to negative. Also, when the value of resistance is raised, the current starts to travel slower, and when the voltage is raised, the electric current flows faster. Based on the data recorded in the table, we also observe that with the increasing values of resistance and a constant experimental and theoretical voltage, the experimental and theoretical current decreases.
Analysis. Through the results showed in the table, we further analyzed that the changes in the value of resistance affects the data. We can say that as the resistance increases, the current decreases, while the voltage is held constant. The lab experiments showed that the current flowing the circuit is directly proportional to the voltage and inversely proportional to the resistance of the circuit.
Using the given formula for Ohm's law, we have computed the value of theoretical voltage and theoretical current. In trial number 3, the experimental voltage and the theoretical voltage had a small difference of 0.1 volts, while in trial 1, 2, 4, and 5 arrive at the exact value of 20 volts. In the experimental current and theoretical current, the values are exactly the same. Thus, both experimental and theoretical voltage and current are quite the same, but there is only a slight difference in one trial due to the variation of the number of decimal places.
Based on the experiment we performed, we have verified Ohm's law principle using the FET simulator and by computations, which states that the current is directly proportional to the voltage and inversely proportional to its resistance. We conclude that the relationship between the current, voltage, and resistance is evident throughout the experiment. In addition, the FET simulator and through computations are both recommended tools in determining the principle that governs Ohm's law and to identify the voltage of the battery, current flowing through